Sorry guys about this. Well, my computer was crashing meanwhile inside, streaming pretty decent. Well, hopefully it doesn't happen once again. So, what I told you about the reticle pointer, we already talked about this, or I already did. We're gonna have the DVR editor emulator where we are going to emulate the controls directly inside Unity, and then we have the event system over here, which is actually taking care of that whenever there's an event happening, that the reticle pointer is going to react to it. So what we now can do is we can already go inside some settings over here, which we need to do to get the VR actually working. What we also want to take a look into is the GVR reticle pointer color, which you can go here. It has its own shader, and you can decide if you want to have it a white reticle pointer, or you can also make this one a black one or red or whichever color you are liking. Also, you're gonna be able to take a look into the diameter, like the inner diameter and the outer diameter, how big the reticle pointer is going to be, as well as the distance in meters. I think that is how far an object is going to be away before this is actually reacting, or at least you're gonna also have a maximum reticle distance over here, like once again in case of units. I'm not quite sure if there is the distance in meters anyhow related to these, but you're gonna take a look into these settings on your own. So what we are going to be able to do with that is, of course, we can now set up everything which we need along over here. So we need first, of course, make sure that our actual scene is inside our build, and we're gonna need to change the device later on so we can make a real build for this as well. So first we go to File, Build Settings, and we're gonna make sure that we are going to add our open scene. And then what I want you to do is you wanna, of course, since it's a Google Cardboard, it is Android related, so you need to have Android installed over here. Also, you need Android Studio and all the other stuff. So I'm gonna change or switch the platform right now. Probably it's take a second, or it's taking a minute or two. And meanwhile, that is going to take care of that. We're gonna not able to do it, or we are not able to do anything. Once it's done, we're gonna see that the basics or the actual Android is going to be seen over there, as well as everything should be done in the center over here. Once again, sorry for the crash a minute ago, or 5 or 3 minutes ago. Well, stuff happens, you know. Okay, so meanwhile we are waiting for this. We basically cannot do anything, or not much at this particular point, and we need to wait until all the controllers, all the scripts, or everything is going to be changed to be, let's say, useful for Android, like reduced in graphics and all that stuff. There are several things happening over here. You're gonna see right now everything works, so we are back to where we need to. And what we want to go first is we want to go to the player settings over here. So what you want to do is probably give yourself a company name. That for me, it's probably going to be OctoMan, but for the moment that's not really important over here. Hi E-Roll, thanks a lot for tuning in. Sorry for the crash. If you I hope it's not going to crash once again. So, and we're gonna take a look into some settings. So the first, and some of the important ones at first. So we are scrolling down inside the player settings from the project settings. So project settings, player, we're gonna go to XR settings. And what you're gonna see is here is something called virtual reality supported. You wanna highlight this one. And of course, we need to enable a virtual reality SDK. So which one we are going to make use of? In this case, we are going to add the cardboard, since that is what we are aiming for. This is going to take a sec or two, since cardboard needs to be activated completely, so we are able to make use of that. Of course, if you need anything else over here, then you can enable this, but this is the absolute minimum and minimum basics over there for the cardboard VR to be supported. So the next one is we want to make sure that in our, I believe it's in other settings, we're going to scroll down a bit. Before you do anything, you want to make sure that you put in your company name. For me, it's like OctoMan, and then probably something over here, VR basics, whatever, you can name it whatever you like, it's the product name. And super most important one is the minimum API level needs to be KitKat 4.4, so API level 19. You need to make sure that this one is activated. Next one is we're gonna take a look into the orientation and resolution representation. So first and foremost, the default orientation over here should be landscape left. This is actually quite important, I would say. Basically, it's rotating around the device. So, but keep in mind that landscape left is going to be or should be your default orientation over here. There's also another setting we need to take a look into is once again inside other settings. I'm gonna scroll down a bit, so where our graphics APIs are going to stand in. Since Vulkan is not supported by VR content, you want to make sure that you get rid of it. So you press on the minus over here, so you only have the OpenGL ES3 inside this graphics API level. So that's everything for these settings. Okay, so don't forget to save. I'm gonna close. I just in case save this once again. There's something like getting available API levels, so probably my SDK tools are a bit busy today. And so we're gonna have like most of the important content done already. So we did created all the settings, we set it everything up so far. And we're gonna once again have the Reticle Pointer. We can tint this whatever we like. And what you can see now here in the game view is that we have a left eye, right eye, both eyes, and an occlusion mesh settings. So we basically don't care about these since they don't. Yeah, we cannot do anything. Even if we go both eyes over here, we don't see any difference. Even if I press play right now, and I don't do anything basically. You're gonna see in the center is now a black point. So this is the Reticle Pointer over here. And I can hold down the control key now and move the mouse. As you can see, something is actually happening over here. And which means it is like tilting left or right. So when I do that, there's also a gap, so you cannot overdo it too much. And if you let go, it automatically goes back over here. You can do the same with the Alt key, so you have like something like a look up or look down with the Alt key over here. You can also look around with the Alt key. So basically that is the actual head tracking, which is automatically done by your device with the, I believe, the gyroscope. So if you have no device which is supporting a gyroscope, then you actually probably get a better one. Okay, so take a look, or let's take a look into the stuff about the Reticle Pointer as well as positioning our actual cam. I'm gonna create something like a small scene over here. Maybe we're gonna put a plane. And I'm gonna, let's say I'm gonna reset this one. Maybe a plane is not too cool, but let's put our camera rig like above the actual plane over here. So whenever we are now going to play once again, we're gonna get our Reticle Pointer, and with Alt we can basically now look around. We can look into the sun from the skybox, and we can basically take a look into everywhere. What will happen if we are now going inside the camera rig's main camera, which is currently sitting at 000 onto our camera rig? What will happen if we move this like here? I'm gonna press play and you're gonna see what's happening with the main camera. It will automatically zero out itself. So that's why it is important that we have a rig which is basically taking care of the actual position over there. So as you can see, main camera is automatically always hopping onto position coordinates 000. So when later on we are going to create something with these games, we want to make sure that we move the actual camera rig and not directly the camera. But what we can do is with the camera, we can read the actual rotation on different axes. For example, onto the Z-axis, if we're gonna do something like a left and right head movement, basically, when something is flying in the direction of us, that we are able to see, okay, there's a negative angle, so negative Z. We wanna maybe move the cam rig like to the left or to the right, based on this own settings over here. Hey Ansel, thanks a lot for tuning in. I'm glad you're here. So, and yeah, let's go forward. What can we do with that? We can basically now put any objects into our scene and try to react to it. And let's try this out. So I'm gonna maybe make a cube. I'm gonna reset this one so we see this one. It's like under ourselves. I go to 3D view and see where it is so we can make or take a look into this. Somehow my lighting seems to be a bit crapped over here because auto generate lighting is disabled. So I'm gonna let it relight over here. Pretty good. So what we need to do is to interact with a cube, for example, and to make use of our reticle pointer so he's actually seeing that there's something going on with that. You're welcome, and so I'm glad you like them. We want to make sure that we have something on our cube which is actually getting information, or actually the reticle pointer gets the information. So let's take a look into event systems, and I believe there's one specific event system we need to put in over here. So I'm gonna put an event system over here, and let's see if there's anything we can do with that. I just put an event system over here and see if that already works for our reticle pointer. Nope, it does not. As you can see, a normal event system doesn't work. But I guess there is something. I believe there was something. There is some component over here which we can make use of. So, and we're gonna have a GVR. Oh, let's see where we got this. Maybe we're gonna have a GVR reticle or an event handler pointer graphics raycaster. I believe that's what we need over here. So, and let's see, where do we need to put this? Graphics raycaster. Probably it is sitting directly on our main camera or directly on the reticle pointer. Let's see. I'm gonna put this maybe on my camera rig and see where we can or what we need to do here. So a graphics raycaster for there's also a physics raycaster, by the way, so probably we're gonna need to take this. So a GVR, a physics raycaster, a graphics raycaster, there's a physics raycaster. I believe we need to put this script onto here, like that we are able to shoot a ray, but I'm not quite sure if that needs to be like on the camera, on the GVR reticle pointer, or on the camera rig. So once again, I'm gonna put the event system once again onto my cube and see if that makes any difference, just to, yeah, get an idea about it. So I'm gonna put, once again, maybe there's also an event editor emulator. No, there's not. There's an all events trigger, but I believe a normal event system is probably taking this in here, or it needs to be different. I don't know. Let's take a look. If not, we're gonna be able to check it out. As you can see, nothing works over here. That can have multiple problems. So it also tells us that the SDK cardboard is not supported, no problem overall, as well as the camera clipping plane needs to be reorganized. We're gonna take a look into this a bit later on. So let's see what's going on with our actual DVR pointer raycast. I'm gonna put this on the main camera and try again. I hope that worked. Okay, so the reticle should open whenever it is like over something. So we can also use any specific raycaster event mask over there. And if that doesn't work, we're gonna try to make use of that directly in the DVR reticle pointer and see if that works. So it is necessary that it is a physics raycaster. Probably that thing needs to have a rigid body component. I don't think so, but well, let's test it out. Rigid body 3D. We don't want to use a gravity over there, so just a physical component. We want to see if we can anyhow trigger this reticle pointer over here. I'm gonna take a look into my notes. Probably I missed something over there, and for this particular ones, or you guys got an idea. And I know that this graphics raycaster, or not the graphics but the physics raycaster component, needs to be somewhere. That's what I know. Probably it's not at the right spot over here, but maybe on the camera. I don't know. Maybe it doesn't matter where it is. So maximum raycast hits 64. That's okay, no problems overall. But what do we need to have over here to get the reticle actually react? I don't know. I forgot what it has to be. Maybe we need to put in a event, not an event system, but a, let me remove this, but maybe an event trigger. Let's take a look into event triggers. And we're gonna add a new event, maybe something like on pointer exit or enter or whatever. And maybe put in, I don't know, the cube over there. We basically shouldn't have any, or shouldn't need to have any functionality onto this. But now you can see, oh yeah, that's good. So as you can see now, the reticle pointer, whenever we are over the, have your Steam account? Yeah, I got a Steam account. What you can see is now when we got this event trigger running over here, I believe we don't even need to have the cube inside because that's for just for functions later on. We should be able to interact with the actual cube now whenever we are over it. For example, when we hover over the cube and we have a script running, something like change a color whenever we click, or change a color whenever we just hover over, and when we hover exit or pointer exit, we're gonna switch back the actual color, for example, of the cube. Let's try that out. I mean, nothing fancy with that. I just create a new C# script and call this one, I don't know, cube stuff. And of course, let the compiler run pretty quick. And on my cube again, now put a, yeah, something like the script directly on it. Anyhow, the default material is so huge. Gonna drag the cube script over here. And I double click to open. This can take a minute over here since I'm using a pretty strange mono behavior version. I'm not using Visual Studio, so my settings are a bit different over here. No problems. Still everything should still work. So as you can see, Reticle Pointer pretty good. We can also put in some inputs and all the other stuff. We basically don't need to. Like we could basically make a joystick working or stuff like that. I'm gonna block this now, and I'm gonna need to put this in here. So, and when we want to do something with that, I need to wait until everything has been loaded. We basically just create our own functions. For example, it needs to be a public function, otherwise we cannot access it, and it's like of type void, since it doesn't really return anything. But what we can do is we can change the color of the code or of this cube whenever our reticle pointer is over the actual cube. But we need to have the event trigger system once again running over there. So change color, something like that. And we can do something like whenever we enter or exit, let's say change enter color, and then we're gonna do something like change exit color. So you see what's going on over there. Change exit color. So what we can do is we can basically get the component of our object which has a material on it, or should be, no, it's not a material probably. We're gonna take a look into the mesh renderer first. So we talk to the mesh renderer, open close parentheses, and in here we should have a material or multiple materials. Probably we need to take a look into shared materials, depends on how many there are. And we can take a look into the color. And the color is basically going to be equal to, we can now put in any new color 32 if we want to, with alpha, gamma, whatever. And we can put in any color basically. There's also another one, which is going to be like, let's see, material color. We can say something like color.red, for example. So we can, whenever we enter now with our counter down over there, or with our reticle pointer, we can hover over that, and we bring the color to be red. And if we are basically exiting, we're gonna do something like color.white or black or whatever. And we can also perform a click. Like with the mouse button, basically, it's about the same, since the actual magnetic key is basically seen as the same. And whenever we are done, we don't forget to save. I don't know if I have saved right now. I believe so. We're gonna make sure that our cube, of course, gets now its pointer enter script. So we drag in the cube and see where the event trigger, the cube is. And there's a change enter color. And we can also create another event where we say pointer exit. So on pointer exit, we want to change exit color. Let's see if that works. So we press play and see what's going on when our reticle is like over the cube. As you can see, the cube is directly accessing the material onto the mesh renderer from the cube. Once again, depends on the pipeline you're using and stuff like that. But the normal way is just that. And when we now leave it, you can see that the reticle pointer is, of course, going downwards, and the actual cube is now changing back to white. And we can basically do this as fast as we want to. So we can basically now see that we are able to interact with objects just by using the actual event trigger, using the GVR reticle pointer connected with the GVR pointer physics raycaster. So this is actually important that the pointer physics raycaster is on that. If that is not the case, gonna disable, I'm not quite sure if that even works, but if we would disable the actual reticle pointer, you can see nothing is working over here because we don't shoot a physical raycast into the direction of the reticle pointer. So once again, I believe we could even put this onto the main camera, maybe not on the rig because we do not rotate the rig itself, we are rotating the camera directly as a child of the rig, and the rig is just here for keeping track of the position of that. Okay, so now we have something to work with. We can also now say if we hit the magnetic switch onto the cardboard, there are also probably there are hundreds of different possibilities for cardboards, not just the cardboard. You can basically do shooting with the magnetic switch. So whenever you hit like basically the left mouse button, which is also responsible later on for the magnetic key, then you are able to shoot balls, I would say, like shoot any projectiles if you want to. But you are basically going to stay most of the time directly where the camera rig is. If you want to move the camera rig like with something like moving left and right, so we can, for example, do something like a void game where we're gonna have to avoid obstacles which are probably going into our direction. We don't want to crash into them. Then we should be able to do this as well. Of course, the camera needs to have a collision objects and everything is about the same, but we just need to take a look into the tilt of the main camera itself, so we are able to when we are doing a left head tracking and right head tracking, that we are able to avoid these obstacles whenever they come to us. This is super simple, nothing fancy. We could basically create some obstacles or something actually, and try to avoid them by just moving right and left. But we can also check this tilting directly within over here. So for our camera rig, so we're gonna need to have another script which is responsible now for this head tracking, and you will be surprised how easy that is going to be. I'm gonna name something like head tracking. Probably there's something like this already. I'm gonna name this something like move camera or move cam. I wait until the compiler runs, and of course I want to make sure that I double click to open once again my strange fancy mono behavior or mono developer is going to load over here. It's always going to request, if it can, enter the internet to create a build, since it needs to be built most of the time or every time I create a new instance of that, but nothing fancy overall. So what we want to do is basically we want to do head tracking, and the head tracking is nothing else than a rotation over the camera. So when our camera is like rotating into a negative direction or positive direction on the z-axis. I'm gonna take a look into this. So as you can see, this is the forward axis, and when we would rotate our main camera, you can see that we have positive and negative z values. And what we can do is we can track these values because the camera is doing the tracking based on the head. If you're going to take a look into right or to left, then you're able to take this as, let's say, as a secondary controller, because the cardboard does not have any gamepad or stuff. It just has the magnetic information, like the magnetic switch. But even most of the or some mobile phones do not even have a magnetic switch built in, so you need to take a look into this as well. So probably it doesn't work with the magnetic switch overall. So when we are going to take a look into that, we just want to see what the camera is actually doing over here. Is it set to be 0? Is it like a negative, or is it a positive number over there? So, and we can track this like easily. We can just say if it is a negative number, then we do this, like move the cam to the left, or if it's a positive, then we move it to the right. So the movement is just like a straight movement onto the x-axis in my case now. Once again, we can later on, or you can later on, do everything else. Once again, that has nothing to do directly with the camera, just a rotation. Otherwise, you would need to, when you would move or want to move the actual camera or the camera rig like in any direction, then you also need to rotate the camera, or actually the camera rig with the camera wherever you're looking at. That's a bit tricky, I would say, but let's take a look into the head tracking now. So what we can do in our update loop, you can probably also use the late update loop. We can do something like if camera.main.transform.rotation rotation.z. So once again, the z rotation over here, why is that red underlined? I don't know. Is smaller than 0 or something like that. I don't know if that works. We're gonna see that. If that is smaller than 0, so we do a left-sided movement basically, or left-sided rotation with the head. So we know that we're gonna have to do something, and in this case we wanna move our actual game object to the left by, let's say, a specific speed. So probably we're gonna put a float speed equals to, I don't know, 10f or 5f or 2f. That's something you need to figure out later on. Let's say 5f, and we're gonna have something like in the positive direction. So basically, if the camera rigs or the main camera's rotation on the z-axis is bigger than 0. What we want to do meanwhile that is we want to move our current position. So the transform.position, we want to put this into a new position basically. So we can add something like, we can say plus equal new vector 3, and then we can put in something like 0, 0, 0. We don't want to do that something, but we now need to move that, for example, onto the x-axis. I would try that at first. So what we want to add now is our actual speed variable times time.delta time. I don't know if that works, but we'll see. We can also do something like transform.forward times speed times time.delta time, or transform.right or transform.left, and what so on. Times time.delta time. I don't know if that works. We're gonna test it out. And of course I want to do the same. Maybe when we are going left, we want to negate this over here, and if we are going to the right, we want to go and add to this. So probably we're gonna do it like this. I don't know if that works. Let's see if that does. We're gonna put the cam rig or the cam script now onto the camera rig, since we want the camera rig to move. So we're gonna put this over here and press play and see what's going on. I don't know. So what we want to do is, of course, whenever we are doing tilting, we want to let our object, like our camera rig, now move to the left. I hold on Control, and if I tilt into one or the other direction, you can see now that we are going to do this movement like based on the tilt. So we can basically now avoid things which are coming from the left or to the right. You can also see if I don't do anything, I still keep on moving, because, well, we just got one single input and then it stays inside over there. So probably we're gonna put an else if statement over there, and maybe another else statement over here. something like if it is equal to 0. I'm not quite sure if that even happens, if that is equal 0. As you can see, it's like underlining this one with yellow, meaning it might not be possible to measure this. We don't do anything basically. So we're gonna say, what can we say over here is equal to, I don't know. I'm not quite sure if that even is possible to do this. So since we are, nope. That's interesting, since I did use the left mouse looking around now. It still takes that into consideration. So let's take a look into the main camera. It doesn't even have something over here. Probably gonna need to do something with the speed over there. What I also don't know if we can do something like that. That transform position is equal to transform position. Maybe we're gonna need to catch our actual position over here. I don't know. I have no idea. Let's just test it out for the sake of, yeah, testing. Nope. Okay, so that's not cool. Actually, it does what it should, but it is, well, a bit picky. So, maybe we're gonna set the speed just to 0 over here and set the speed over here to whatever the speed is. So, something like float current speed. And so we say something like current speed is equal to speed. And so we're gonna take current speed here into this, and current speed over here. We're gonna copy this as well, put this over there, and over here we just probably do something like current speed is equal to 0. Maybe that makes sense. I don't know. If that doesn't work, we can just say something like else and then only set just the current speed to something. Yep. So we basically don't care about the actual transform or anything. We just say else current speed equals 0. So let's take a look into this. Once again, since creating games is for VR is a bit different. That's awesome. It doesn't really reduce the Z value. Maybe we need to put something like an offset. If that is bigger than 0.4 or smaller than 0.5 or 0.1 over here, smaller than a negative 0.1, maybe that makes more sense than 0. 0 is probably a bit too picky. Let's see if that works. Yes, there we go. It's a bit fast, but it does what it should. Decent. So, and what can we do with that? Well, we can now put something together like an avoidance game. For example, we can bring some cubes or some buildings or anything, whatever we like. We can, for example, make something like this. So we don't see anything. We can maybe change the skybox to be a solid dark color or something. So we gonna see a bit better what's going on. You can always, of course, create materials and stuff like that. And what we can now do is we can create some prefabs, which are just, cubes. And we can make them any high, however high we like to. By the way, we need to probably put some limits to the camera here as well, but like for the game itself, whenever it would be something like a game. And what we could do is something like, okay, we're gonna create some prefabs like at any point, like over here in the background somewhere, I don't know. And we're gonna do something like walls. So what we need to do is we need to avoid these walls whenever they are like moving into our direction. So let me do something like this. They don't need to be physical. Probably you can also do something like with shooting that things over using the magnetic switch and the reticle pointer. I'm gonna deactivate this cube. And what we want to do is, for example, move this thing like over into the direction of our player. We can also create prefabs once again out of that. Basically, it doesn't really matter. And probably gonna put some empty game object below them, like they're having the same, you know, the same settings over there. I duplicate this maybe and bring this over here to the other side and make it a bit slimmer. So we have something to actually avoid. Limiting the movement of the camera rig is probably best using a rigid body component. So something like we put an invisible wall next to the player over here and make sure that the camera rig gets or has a box collider on it. Let's test this out. So we're gonna put a box collider onto the main camera over here, and this needs to also be for limiting the actual input, and that's the super easiest possibility I can think of to block things moving over a specific, let's say, corner or something. So what we need to do with that is that needs to be rather huge, I would say. And I'm gonna resize that to be something like this. And this is just our wall, or a blocker. And you're going to be able to put this like, you duplicate this, bring this onto the other side if you like to, something like that. And our main camera rig needs to have a rigid body component here as well, without any gravity. But what we need to do is we want to make sure that we freeze rotation. So we don't want to rotate that camera rig at all when we just move left and right. Let's see what's happening when we do this. So we're going to have like trigger colliders. And as you can see now, it's jiggling. The actual box collider is jiggling, but as you can see, we are able to move just to the point where this rigid body is going to be, and we're gonna update this accordingly. So once again, based on the actual input now, we're gonna be able to do that. And the last stuff is just like rotating around. Well, we can always look around, no problems overall, since the head tracking looking left and right is happening over to the y-axis, so we don't care about this. But let's take a look into this. Maybe we can also make the use of that. So nope, that doesn't work. That's good. So it's blocked. So we are basically not able to do movement. Meanwhile, we are like hitting the Alt key over there, so we can look around pretty good. But we can only move whenever we tilt the head left and right. Pretty decent. And also, you know, most of the time do not tilt your head so much. So probably you're gonna take a look into the speed later on as well. Okay, and the final step for a game or for a working game to get some score and stuff like that is basically just move these little cubes over here. So probably I'm gonna create an empty. I'm gonna make it so that it's like on the y is going to be at 0, for example. We're gonna put this maybe basically it doesn't matter where we put it. Something like in the center maybe of the playfield, so on X and Y 0, and this one here is basically related to the actual prefab, and put something like this. And the final thing is just whenever we just now need to move these things like over the z-axis, or in this case the negative z-axis, so it can go against the actual player. Later on we're gonna have multiple things of that. So this is something like a obstacle. Of course, you can put in all the mechanics later on for doing like collisions and stuff. So whenever we collide with an obstacle, that we reduce ourselves alive or whatever. We can also define later on the movement speed and all the other things. So gonna create a new C# script for an obstacle. And whenever the obstacle is like behind the actual camera rig, then we want to destroy it because we don't need it anymore. And of course, we open this in Mono Develop, Visual Studio, whatever you're using. And we are good to go, basically, I guess. So, and we just moved this one along. Once again, my firewall rocks the world over here. And meanwhile, we are in update. We just implement the actual Z value, the negative Z value over time and speed. So once again, we're going to put in a float speed. We can set this one to be equal to, I don't know, 10 or whatever. And we're gonna have, later on you program in something like if somebody has too much points and so on, you're gonna increase the speed of all these obstacles. You can also set them by code later on and so on and so forth. So what we wanna do is, of course, we wanna add to our transform.position plus equal a new vector 3. And now we're gonna put the 0, 0, 0 as usual. And where we wanna move is basically the negative z value over here. So we say negative, or we're gonna say something like speed times time.delta time, or we can also negate speed. So we have a minus speed on the z value. We are good to go, I guess. So the final step is, of course, we need to create a connection for our obstacle to the script. So we just drag it on it. Maybe we're gonna put or get rid of the box colliders from the cubes, but make the obstacle having all this information. So we're gonna later on see if that works. Also, you probably want to give score when somebody is passing the middle area over here. So basically you create another cube, bring it over here, make it a bit wider, so it is getting better recognized, something like that. But we're gonna disable the mesh renderer, so over here there would be like a score field, and of course this needs to be like a trigger. And basically, once again, all these components are super simple to get together, and that's it. And we can now duplicate this. I don't go over the spawning right now. This obstacle, or let's take this one. I'm gonna just change like the sides over here, wherever it was. So I'm gonna put this to here, and the score field is going to be over here. So, and that's basically everything. So when we now hit play and we are like in our VR interface, you can see that these things are now going to come in here, and we have something like a flight simulator style game where we need to avoid these obstacles over here. Once again, you can get rid of these obstacles whenever they are like behind the camera, like 2 meters or 5 meters behind the camera. So every obstacle, just take a look into his or onto his own. We're gonna put, or you're gonna put probably something like a spawn object over here where you can spawn multiple obstacles over time. So we have like an unlimited